Hello students, this is Akshay and you are watching your favorite channel Alpha and Omega, and in today's lesson we will move forward to learn about the types of vectors and its representation in a 3D space and a 2D plane as well. So without any delay we will start the lesson, but before discussing anything I want to discuss some important things that in the last lesson, in the last video lecture, we finished up about knowing the operation of vectors, right? And we also came to know about the features of the vector and its definitions and its representation as well. Okay, so in today's lesson we are going to learn about the types of vectors and its representation in a 3D space as well as in a 2D plane. Okay, so without any delay, let's start the chapter. So in today's lesson, as we already discussed, that we will learn about the types of vectors. So if we discuss about the types of vectors, so types of vectors, then there are multiple types of vectors, okay, which have different sort of features. Okay, so first type of vector that we will discuss is a zero vector. Okay, so zero vector is a type of vector whose magnitude is zero. Okay, so basically it's a feature of vector in which we can use a vector in a geometry as well. Okay, because you know that in arithmetics basically we use a zero as a number. Okay, so zero is a number which represents nothing. Okay, so in a similar method as we use the arithmetics in the geometry, okay, to measure, to scale up, or to know the magnitude of any line, similarly we can use that arithmetics in a vector as well. Okay, so in a zero vector, basically the vector whose magnitude is zero is simply known as a zero vector. Okay, so if I say this is a vector a bar, okay, so a underline this is a vector, okay, or you can represent this as a vector as well, okay, like this also. Okay, so this is a vector, okay, its magnitude is this, okay, and its direction is a cap. All right, so the magnitude, if the magnitude whose magnitude is zero, that means it is a zero vector. Okay, so basically if there is a vector, see, if there is a vector whose magnitude is zero, that means that vector is also called a zero vector. So simply the vector whose magnitude is a zero, and basically you know that zero multiplied or times with any other number or any other quantity, it is always equals to zero. That means this vector is also equals to zero, and this is called a zero magnitude and zero vector as well. Okay, now let's find out what's the other type of vector. The next feature or the next type of the vector is basically what? Unit vector. Okay, so now we will discuss about unit vector. So unit vector is a vector whose magnitude is always 1. Okay, so gradually we are moving on the counting, like 1, 2, 3, like that. Okay, but it's important. Two vectors are very important for us, zero vector and a unit vector. So unit vector is a type of vector which has a magnitude always 1. So unit vector is a vector in which if I have a vector, okay, in which this is the a vector's magnitude and this is the a vector's direction, then if I say that the a vector's magnitude is 1, okay, that means it is equal to, if I put the value of the a vector's magnitude here, I will get what? A vector is equals to a cap only. That means this vector is used to tell only the direction. Okay, it is useful for only direction. So a vector has a direction only, okay, and its magnitude is 1. So such unit vectors are basically used to describe the direction of any vector or any specific quantity, like force, okay, like pressure, right? So it's basically representing the direction only. Okay, so now what type of unit vectors we use in the mathematics? Okay, so simply if I say that I have a line, okay, this is a ordinate, okay, and this is abscissa, okay, and this is a coordinate geometry, okay, This is ordinate, okay, and here if I say that this is the origin, okay, then this I can say that this is x-axis, this is x dash, and this is y-axis, and this is y dash. Then in that manner I can say that in this coordinate geometry, if I represent any point, if I want to go in any direction, then how can I go in that direction? If I say that I start from origin and I go on the y-axis plus y-axis, so in which direction I am going? So y is not a direction. So if I want to show some direction, then the direction of the y-axis is always called j cap. Okay. So basically j cap is a unit vector. All right. And here, if I go from the origin in the negative direction, this will be the negative j cap. Okay, so basically it is a unit vector which is representing only the direction. It doesn't have any magnitude. If you multiply this direction with any magnitude, that becomes a full vector. Okay, now similarly on this x-axis, this abscissa, if I say this is I cap. Okay, this is a positive I cap and this is a negative I cap. Alright, so negative I cap is the basically same, we are moving on the x-axis but in the negative direction. Okay, and similarly if we are moving on the x-axis in the positive direction, then I will say that it is positive I cap. Okay, and this is a 2D representation. If you say like what if we have a third axis, that is z-axis also on it, then what will be the answer? So in that way, if I make it like the third axis like this, okay, then in that way I can say that this is z-axis, then this z-axis is represented as k cap. Okay, so from origin, if I come outside like this on this plane, on this line, right? So then this will be k cap, and if I move in the negative direction, like this, right? Then this negative direction, it is basically what? Negative k cap. So I hope you understand that there are multiple type of unit vectors that we use in a mathematics. Okay, so I cap, negative I cap, j cap, negative j cap, k cap, and negative k cap. Okay, so k cap is representing movement on the z-axis, I cap is representing movement on x-axis, and the j cap is representing the movement on the y-axis. So in that way, you can easily say that that whenever I make movement on x-axis in any direction, I will represent that movement, the direction of that movement by I cap, and the direction of the movement on the y-axis will be represented by j cap, and the direction of the movement on the z-axis will be represented as a k cap. Okay, so positive and negative symbols are represented to go forward and backward, or like a movement on the positive direction and the negative direction. This is very easy for you. Okay, so now these are the unit vectors, so we can mark it up here like this, that we have I cap, okay, j cap, and k cap. These are basically what? The unit vector. Okay, further, next type of vector, we will learn that how to represent the position of any point in any plane and in any space by using these unit vectors. Okay, so let's move ahead and let's know that what is the next type of the vector. Okay, so the next type of vector is basically what? Position vector. Okay, so the next type of vector is what? Position vector. Position vector. Alright, so the vector which is representing position of any point in any plane or in any space, that vector is basically called what? Position vector. Okay, and the position should be well defined with respect to what? Okay, if you say that I am at 3 kilometers, so this is incomplete sentence, right? So you should say a complete sentence that I am at 3 kilometers from my school. Okay, so that means you are telling a reference point and then you are telling your present position. Alright, so in both terms you should be very clear that what is your position. Okay, so basically the vector which is used to represent the position of any point in any plane or in any space, that vector is known as position vector. Alright, so how do we represent it? Okay, so basically we can represent it by a simple method. Like if I say that this is a ordinate, okay, and let me represent it by red, or let me use the blue one for x-axis. All right. Okay, so we can clearly say that this is x. First, I will explain you how to represent in the 2D vector, right? In the 2D plane. Okay, so if I say that I want to represent the position of any point here. This is a point, okay, and this is a point of which whose position I want to define. All right. So first of all, to reach at this point, how would you have moved? Okay, so if I say that this is origin, this is x, this is x dash, all right, this is y, and this is y dash. All right. So now in this feature, we will know that if I start from origin and start traveling on the x-axis, as we discussed earlier, that if I make a movement on the x-axis, I will represent the direction of the movement by I cap. All right. I'm moving on the x-axis, okay, positive x-axis, and in the positive direction I'm moving. All right. And if I make some movement and first origin to here, I need to move here. Okay. From origin to here, let's say I moved x steps, okay, in the direction of I cap. So this becomes x I cap. Okay, this is a magnitude and this is a direction. Magnitude and direction makes what? You already know that this is a vector. All right. Similarly, and if I move on this line again, let me represent it by red color. So if I move like this, then I can clearly say that first I came here and then I went upside. Alright. So right now I'm moving on the ordinate. This was abscissa and this is ordinate, right? So in that way I can say that I moved upside. If I move upside, then I can say that clearly I moved y steps, okay? I moved y steps on the positive j cap. If I move that downside, that would be negative j cap. Alright. But if I move upside, that means on the positive side, you already know that this is represented as j cap, right? This is positive j cap and this is negative j cap. So in conclusion, I can clearly say that what is right now my position is basically represented by this line, okay, and this line is representing what? My position, okay, and this is my final position with respect to origin. Okay, so if you start from this point, you gradually move down here and then here, then what is your right now, what is your current position? Your current position here with respect to this point is this. Okay, this line is showing your present position. I hope you understand. I hope you can visualize this. It is very easy. Alright, so now I can clearly say that this is a position vector. Okay, if I say that this position vector is R vector, basically it is a resultant vector, right? It is a result of these two vectors. So then I can say that if this is origin O and this is A, this is B, then I can say that OB vector is equals to OA vector plus AB vector. Okay, so in that manner I can clearly say that OB vector is a result of addition of OA vector and AB vector. Here you can say that OA vector is equals to xi cap. We can know that, we can clearly say that OA vector is equals to xi cap. Alright, and OB vector is equals to yj cap. As a result, what can I write here? That OB vector is equals to xi cap plus yj cap. I hope you understood it very clearly. So this is representing basically a vector. So OB vector is what? The final position of point at point P with respect to origin is basically what? OB vector, which is equals to xi cap plus yj cap. I hope you understood it very clearly. This is a position vector. Okay. We also can represent this position in any space as well. Okay, for that purpose, we also need to represent a 3D space. like another axis, that is z-axis. Okay, and I know that you would have some questions regarding the other planes as well. Okay, what if I want to represent the position here in the first quadrant? Okay, or you may say this is first and this is second quadrant. So if you want to represent the position of any point in the second quadrant, that will be also a same sort of stuff, but you need to change minor symbol changes. And what kind of minor symbol changes we can make? Let me show you. If you want to represent the position of this point, let's say this point you want to represent. Okay, so how would you represent it? So first of all, what you did? You need to travel on the x-axis, x dash, right? You need to travel x-axis, but in the negative direction. Initially, you was moving on the positive axis, right? So here, what you will do? First of all, you need to travel from origin to here. You will travel on a horizontal direction first. Alright, and you can clearly say that what if I first travel on the y-axis? It will make no changes, right? It will make no changes. You need to take this and this, and then you can take that way also. Okay, so now at the second you need to travel on the ordinate as well. So let me change the color. So if I take this direction, okay, then I can clearly say that from here to here, I moved from here. Okay, and if I say that this point is let's say P, and this point is a Q. Okay, then I can clearly say that if I move from origin, okay, point of reference, and then I moved to point P, and then I moved to point Q, then what should be my final position? So my final position is OQ. Okay, with respect to origin, my final position vector is OQ vector. That OQ vector can be represented like this. Yeah, it should be like this. Alright, and in this position, this is OQ vector. Alright, and in the OQ vector, you can clearly see that initially from O to P, I moved on like this. X multiplied by negative I cap. Why negative I cap? Because this was a positive I cap. Alright, right now I moved on the negative I cap. I hope you understand it very clearly. Right now I am moving on the negative I cap. So that means it is negative X I cap. Alright, then I moved on the same ordinate, right? Yj cap. So Yj cap. So final, what should be the result? What should be the OB vector? So we already know that what is OB vector equals to? OB vector here, sorry, OQ vector, right? So OQ vector is equal to OB vector plus PQ vector. So we can write it like here that OB vector is equals to, oh wait, not OB vector, we need to take OQ vector first, okay? OQ vector, this OQ vector should be equals to OB vector plus PQ vector. I hope you learned it. I hope you understand the basic concept here, right? So OQ vector. So basically, if I say that this is again the R vector, resultant vector, then this resultant vector R vector is equals to negative Xi cap plus Yj. So this is two different points, okay, in two different planes, and the shown information is basically representing two different informations. All right. So here this is the position of point Q with respect to its origin is basically OQ vector, and it is negative Xi cap plus Yj cap. And here the position of point P with respect to origin is OB vector, and it is equals to Xi cap plus Yj cap. Okay. I hope you understood the concept of how to show the position of any point. Now it's time to give you homework. What will be the position of two different points in this third and fourth quadrant? If you take this, any of them third and any of them fourth, can you represent the position of any point in the third quadrant as well and in the fourth quadrant? This should be your exercise. Okay, I hope you will do at your home by pausing this video. Alright, okay, let's move ahead and let's know that how to represent the same sort of vectors in a 3D space. Okay, so let's understand the concept of representing the vector in the 3D space. So position vector is very clear. The vector which shows the position of any point in any plane or in any space is called position vector. Okay, so OB vector is a position vector here. OQ vector, this OQ vector is also a position vector. Okay, so basically I can say that every vector which is representing the position of any point is a position vector. Here, is this also a position vector? Yes, it is representing the position of point P with respect to origin. So this is also a position vector. I hope you understand it very easily. Okay, let's move ahead and now let's know about that how to represent the position of any point by vector in a 3D space. So if I say that I have a 3D, let me write it first. Like we are representing what? Position of any point in a 3D space, right? So first of all, this is ordinate, all right, and this is abscissa, all right, and the third one I will make like this, and this is the z-axis. All right, so now let me mark it up all the points. So this is x, this is x dash, this is y, and this is y dash, this is z, and this is z dash. Okay, so now we have represented all the directions very easily. Okay, and we all know that this is k cap. Okay, this is represent the movement of direction on x-axis. It is represented by I cap, j cap, and k cap. These are the unit vectors. All right. Now, if I want to represent the position of any point, like what? If I want to represent the position of any point here, how can I represent? Okay. So, what if I want to represent the position here? How can I represent it? So simple. That is a simple. Don't consider this is in plane. It's somewhere here. Okay, it's somewhere here outside. Consider it as a 3D structure. Let me show you a 3D structure and consider one point as the origin. Okay, so let me make a 3D structure first. Okay, so this is a simple cube. Okay, and this is another simple cube. Okay, and let me make a line here. Okay, so now if I consider this point as the origin, okay, and if I want to reach any point, reach here, then you need to consider 3 different directions. All right. So if I say that this is the origin, this is the origin, or you say this is the origin, and you want to represent this position, so it is very easy, right? So if I consider this as the origin, this point as the origin, this is x-axis, this is y-axis. So this is x. Okay, this is y and this is z. Alright, so you want to represent this position. So first of all, you need to travel on the x-axis. Alright, then you need to travel on the y-axis, and then you need to travel on the z-axis. Alright, so first we traveled on the x-axis. Okay, then we traveled on the y-axis, and then we traveled on the z-axis. So you have to travel on the 3 axes simultaneously. Then you can reach at any certain point. Okay, you can understand it very easily. Okay, or you can say it like that, like first I traveled on the z-axis, and then I traveled on the x-axis, then still I reach at this point. No, you will reach at the plane only. Okay, if you really want to reach at certain point, like this point, like anywhere, if I say this point is here, then how can I reach? And consider this point is in a mid of that cube. So if this point, let's say this point is a P, and P point is in mid of that cube, then how can I reach there? So to reach there, it's simple. First you need to travel on the x-axis, okay, then you will travel on the y-axis, and then on the z-axis. Okay, so by traveling on 3 directions, one after another, you can reach in the mid of at that point. Alright, so you understand it. I hope you understand it very easily. Okay, so representing this point will be like this. So the resultant vector can be represented like this, because I traveled on the x-axis first. So this will be xi cap. Alright, then it will be yj cap, And now since we traveled on the third dimension as well, and on the third dimension, since we traveled on the third dimension, it should be what? Z k cap. Okay, so this is how we represented the vector, resultant vector in a 3D space as well. Okay, so we represent the position of any point in a 3D space as well by help of unit vectors. Okay, and here this is also called a position vector. So resultant vector will be xi cap plus yj cap plus zk cap. I hope you understood it very clearly, very easily. This concept was very easy. Okay, so now let's move and let's know what is the other type of vector. Okay, so let's move to the next step and let's find out what is the next type. Now the next type of the vector is basically what? Displacement vector. How to represent a displacement vector? Let's find it out. Okay, so first of all we are learning what? Displacement vector. It is a type. Okay, displacement vector. So how to represent it? First of all, I will make you learn that how to represent it in a 2D plane, and then we will go further for the 3D space. All right. So if I have a 2D space like this, okay, and it is like this. All right. So if this is origin and this is the point at which initially my position was. Okay, and then I move from here to here. Okay, so initially I can say that my position was like this. I was at this point. Okay, and then my position changed to this. I hope you understood. I hope you understood it. Okay, so this was my initial position. Okay, and then I moved from here to here. Okay, then what should be my displacement? So my displacement can be represented very easily by this line. Okay, and this line is basically representing what? Your displacement. Alright, and this is basically should be the direction since you move from here to here. Let me nomenclate them. So first of all, this point, let's say this is A and this is B and this is origin. Okay, so first your position was OA vector. Okay, and then your position was OB vector. If I say this is R1 vector and this is R2 vector, then I can say that you moved from R1 vector to R2 vector. So what should be the displacement? So displacement can be represented by AB vector. Okay, let's find it out how to do it. Okay, so initially we know that first of all, if I say that what was my position initially? OA vector. Okay, that means I started moving from point O, that is reference point. When I started from this point, I reached that position of point A, and then from A I moved to point B. Okay, then I can clearly say that this R2 vector is basically equal to OA vector and then AB vector, right? So I can write it like that OB vector should be equals to OA vector plus AB vector. So AB vector is basically a vector which is representing the displacement of the particle which was moved from point A and then it is moved to point B. Okay, and AB vector is what? A kind of a displacement vector. Okay, so how can I represent AB vector? So here AB vector is equals to OB vector minus OA vector. Alright. Here, if I say that AB vector is a displacement vector, and let's say this is delta R, because this is representing a displacement, right? It's representing a change. So if I say that this is a delta R vector, then I can say that delta R vector should be equals to OB. OB is what? R2 vector. So this is R2 vector minus this vector is what? R1 vector. So this was R1 vector. So I can clearly say that the displacement vector is a difference of two position vectors. Initially we know that OA vector is also a position vector and OB vector was also a position vector. So displacement vector is what? The difference of two positions. Alright? The shortest distance between 2 points. So shortest distance is what? AB. And basically it is representing what? The difference of two position vectors. So if I say that initially the R1 vector was like this. So if I say that R1 vector was like this, x1 I cap plus y1 j cap. And if I say that R2 vector was like this, R2 vector was x2 I cap plus y2 j cap, then how can I represent the delta R, that means changing position? It's very simple, putting the value on the corresponding positions. So here this become like this. So delta R vector should be equal to R2 vector. R2 vector has value x2 I cap plus y2 j cap. Okay, and this should be subtracted x1 I cap plus y1 j cap, which will finally result into delta R vector is equals to x2 minus x1 bracket I cap plus y2 minus y1 bracket j cap. So this is finally a delta R vector, and which is representing what? A final displacement vector. I hope you understood the concept very easily. This was a displacement vector. You can similarly represent the displacement vector in a 3D space as well. Okay, the next vector, the next position will be z2 minus z cap, z2 minus z1 k cap, and this will be a 3D vector in the displacement vector in a 3D space. Okay, so now in today's lesson, this was the types of multiple vectors. Okay, in the next lesson we will learn about features of the vectors, other features of the vector, and then we will perform some geometric operations with the help of vector. For that time, up to that time, I hope you will learn some basic things at your home, at your comfort zone. Okay, and we will see each other in the next lesson. Thank you so much.